Hello everyone, my name is Parisa and I'm the Senior Platform Manager at Galvanic Applied Sciences. Today I would like to talk about a specific application regarding the natural gas liquid industry, so NGL. I will start by introducing the NGLs and then I will discuss some of the key challenges as well as some of the recommendations based on Galvanic's years of experience in this field. Natural gas liquids are the energy components found in the raw natural gas. NGLs are separated from methane, so it can be further processed downstream. The real-world applications for the NGL specifically include petrochemical feedstocks and the cooling fuel. Now, the NGL production itself starts with the raw natural gas brought to an expander plant, as you see here, for processing. Impurities are removed, and the natural gas liquids are all separated from the methane that is used for the pipeline gas. The separated NGL contains a mix of ethane, propane, butane, and all sorts of other liquids. Now, this mix, which is basically the Y-grade NGL, is then sent to a fractionation facility for further processing. Now, as an NGL operator, what matters for you is that the primary objective is always ensuring a smooth operation. Safety is another point of focus, and it's very important to keep everyone around you and yourself out and the operation side really safe. Environmental compliance is also very important to make sure that we avoid getting unnecessarily fined. For the NGL product, you also want to make sure that you meet all of the regulatory and tariff quality specifications. Now, like other segments in the natural gas value chain, the NGL industry faces challenges. Handling NGL is difficult, specifically due to their flammable nature and the pressure requirements. Transportation becomes an issue when managing capacity against production. Fractionator options are limited due to their concentrated geography. There are risks of contract changes when require operational flexibility. One of the biggest concerns for the NGL producer is making sure that they meet all of the specifications of spec NGL can have expensive impact that affects the organization in general. So that's why the NGL relies on tariffs which specify the allowed impurities. Now, all of the points I mentioned here together forces the producers as well as the pipeline operators to pay close attention to the composition of what they are dealing. Here are some examples of the parameters that are monitored in the NGL products. For example, high H2S is caused by an error in the upstream oxygen scavenger injection. If it's a high COS, that forms on emulsive surfaces and can basically fractionate with ethane. We have trace moisture in the pipelines that causes a COS above about 3 ppm to hydrolyze that can form H2S. We have mercaptans. They're not removed by most amines, leading them to cause odor issues. Mercaptans also lead to amine solvent contamination and also polymeric fouling. A high methane to ethane ratio happens if the expander plant is running too cold or if the JT plant does not have NGL stabilizer installed with refrigeration. High CO2 occurs if the plant is running too cold, that causing hydrate formation in the tower. Oxygenates such as glycol or methanol, they're all added as corrosion and hydrate inhibitors. If not removed, these are poisonous to downstream propane and butane processes. Likewise, if not removed from LPG, the corrosion tests may not reveal true conditions. Physical properties can affect the color of NGL also, making it more yellow in appearance. This can be caused by water, by sulfur compounds, dyes, rust from new pipelines, wellhead and treatment chemicals, sand, clay, dirt, gums, gum-producing substances, asphaltenes, scaling, carbonates, sulfates, oils, hydrocarbons, so many different parameters that can play in here. However, there is an efficient way just to make sure that your NGL product, regardless of everything we mentioned here, always meets specifications without you worrying about any of them. All you need to do is basically you want to perform a real-time monitoring for your NGL streams. So basically by using process analyzers that can help streamline production to quickly identify any upset conditions to avoid all of the issues I mentioned earlier. There are several applications where continuous monitoring is beneficial. We'll go through each process one by one to explain all these scenarios. Gas expander plant takes raw natural gas and separates the NGL from methane. The methane goes off to the natural gas pipeline, and then the mixed NGL, which we refer to as Y-grade NGL, that part is sent for fractionation. An important measurement in the expander plant is the demethanizer. Now, if the ratio is not maintained, then the methane will have too much of ethane plus or C2 plus. And ethane plus also will have too much of the methane, requiring additional 1 GC or a gas chromatogram can monitor both the top and the bottom of this demethanizer. So that makes it very easy. You look at the top, you look at the bottom, and you have an idea what's going on in the whole process. This allows for a very quick check and quick operator alert if, for example, the methane to ethane ratio changes or any of the streams has an issue. On the right, you can see a table, you can see an example of the composition for the Y-grade NGL. Tariffs specify the maximum allowed concentration for various impurities. It is very important for the Y-grade NGL buyer to feel confident that the NGL product they are purchasing really meets the specification and requirements. The validation is achieved by using least automation custody transfer, which is referred to as lacked skids. This custody transfer can occur in a pipeline as well as by truck or rail. Some of the most common parameters are monitored in this skid are Saybolt color, H2S, and some stream composition. Now, the Saybolt color can be measured using a photometer to identify various possible impurities. When it comes to the H2S, that can be measured using lead acetate tape to make sure, again, that everything is aligned in terms of what's required for the specification purposes. And also a GC can measure the composition to monitor the full NGL profile specifically as meeting all the requirements that we mentioned earlier. Now, after the lac skid validates the Y-grade NGL, what happens is that it goes to a fractionation facility. Now here in this facility, the mixed NGL goes through distillation steps. And the whole idea is to separate the individual components. Our GC configured with multiple streams can monitor exactly the top and the bottom of several fractionation towers just to monitor the separation efficiency. And here it's very, very important that each component meets certain purity specifications. This is an example of ethane, propane, butane, and pentane plus specifications, so C5 plus specifications. So as you can see, each one will have their own requirements for allowed impurities. Now, unlike the natural gas industry, which is very standardized, the NGL industry has not yet specified universal requirements for the actual NGL products. That's why it is important to review each tariff specifically to understand the requirements that apply in that specific situation. Now, another step performed in fractionation facilities is natural gasoline processing. Natural gasoline is normally referred to as pentanes plus. Now, the debutanizer feed here is distilled to recover the pentanes with hexane plus buttons. Like the other fractionation points, again, a GC can monitor efficiency in this process as well. There is also a color specification for natural gasoline that must be monitored for this process. Photometer can monitor Saybolt color here to determine whether or not natural gasoline needs to go through any decolorizer stage to meet those specifications. The removed color are traces of heavy ends that are found in the debutanizer bottoms product. Other impurities such as corrosion products from the pipeline might also exist here. The removed color bodies leave the decolorizer and are basically injected into a crude line. Now, propane as well as the butane are normally treated to remove H2S as well as mercaptans as well as COS. So these treatment options include basically amine sweetening and mercaptan oxidation. Amine units extract H2S as well as the COS, while Merox units focus on the mercaptan removal. Now, a lead acid tape analyzer here can monitor the H2S as well as the total sulfur for removal efficiency. In addition to that, if specified sulfur concentrations are of interest, a GC again can be used here with a chemiluminescence detector. Now, from a process unit efficiency point of view, a liquid titration analyzer can also be used here in an ADIP unit to monitor the amine strength. When it goes to the Merox unit, then a liquid titration analyzer can monitor the caustic and carbonate. These are important indicator, everything we're mentioning here, because what they do is that they can basically complement monitoring the NGL quality. And you see that we have a solution for every individual point and measurement that is required in these processes. It might seem ironic that even though the Merox unit removes the mercaptan, then later on downstream, again, specific sulfur species are added back to the NGL. LPG is odorized to warn consumers of any leaks. Odorants that are added include isopropyl mercaptan, tert-butyl mercaptan, N-propyl mercaptan, sec-butyl mercaptan, as well as THC, which stands for tetrahydrothiophene. Now, a concern for odorization stations is to make sure that odorants do not fade. Fading can occur during translation, for example, or during storage, as well as from other sulfur species. Now, optimizing dosing is another major concern. Underdosing will not provide enough notice to consumers when there is a leak. Overdosing will spread LPG distribution companies thin, responding to false alarms. That's why using the GC again here with a chemiluminescence detector to monitor speciated sulfur can really avoid all of these headaches together. Now, in addition to the NGL specific challenges, there are analyzer challenges as well. So now using process analyzers from, for example, multiple manufacturers that can create complexity, because now here you have to deal with several points of contacts instead of only one. Each analyzer will have its own dedicated service engineer, which gets really expensive because now you have to bring for every individual analyzer, there should be a specific individual at site. You also need to stock spare parts from variety of these vendors, or else you would risk long lead times in case there's any severe failure or something urgent to take care of. Another challenge that you will have is an overall lack of training. As this knowledge gap occurs when technicians, for example, get transferred to a new department before they fully know exactly all of the analyzer and the process and everything. Or if they're new and experienced technicians, that's another source of the risk. Now, some technologies can also be more complicated than others. That's another source of risk or challenge. Now, without proper training, simple troubleshooting can be really a headache and an issue. Now, one of the most pressing challenges, for example, is if your analyzer goes offline and it's an urgent situation to take care of. GCs, for example, that experience excursions, sometimes it might require the entire guts to be replaced, which becomes very expensive over time. Or if a total sulfur analyzer or a tape analyzer does not have a pressure switch indicator, for example, installed on a hydrogen utility, then the system will coke up and will require cleaning or replacing some of the parts. So the impact becomes expensive then and time consuming. And thankfully, there is a solution based on the approach we took to answer all of these questions and concerns that it can overcome basically all of these issues. And that's by using a dedicated manufacturer for all of your analyzer needs. You'll have the access to all of spare parts quickly from one vendor, one engineer at the site to service them all at the same time. It's easier and it's more guaranteed that you'll have a solution in place for every need that you have much faster. So your analyzers should also guarantee maximum uptime, which provides you with minimal hands-on maintenance, fast speed of response, and also great accuracy. Now, Galvanic is basically a one-stop shop for all of your NGL analyzer needs. We have thought about all of these processes, what measurements are required, what are the specifications for monitoring these processes, and we have a solution for each point, as we mentioned earlier. This includes the photometers for the Saybolt color, the tape system for the H2S and total sulfur, and the GC for the Btu stream analysis, as well as Speciated sulfur. Now, the Saybolt color can be monitored using Galvanic's Monitech photometer. This measurement is basically made during caustic transfer, as well as the colorizing natural gasoline. The configuration is explosion proof, so no purges are required for this system. The sensors are rated for high pressure and use compatible components. Operators receive instant detection for any impurities that could cause color to change. So that's a great advantage to have. For the H2S as well as the total sulfur, this can be monitored using Galvanic's Protect 903 tape system. This measurement is made during caustic transfer as well as the NGL sweetening. PPB sensitivity provides amazing resolution when it comes to detecting upsets. Multi-parameter as well as multi-stream configurations are available with this unit, and that creates a small footprint, which is of great importance. Galvanic's Accuchrome GC, you can measure the Btu as well as the NGL stream compositions. So this analyzer uses a TCD detector to make measurements at the gas expander plant. The metanizer during the caustic transfer and throughout the fractionation process. By measuring up to 8 streams, this analyzer provides a fast return on investment, and you see it's a very powerful analyzer to handle a variety of streams for your applications. Speciated sulfur can also be monitored with Galvanic Sulfur Chrome GC. So this analyzer uses a chemiluminescence detector to measure sulfur during NGL sweetening as well as during the LPG odorization. Every sulfur species can be measured rapidly in just 7 minutes. Even if the product composition changes, again, accuracy will not be affected at all. For sulfur species from ppb all the way to the ppm levels. The analyzer also can help to optimize dosing injection for the LPG odorization in this process. We guarantee the turnkey installation, so we customize sample conditioning systems such as regulating the pressure, the flow, the filtration, And we also provide shelters with climate control whenever necessary. Our sample system interfaces with all of our analyzers, so that reduces the footprint as well. We also offer the local on-site services for all of our analyzers, sample systems, and everything that we build. This includes startups, PMs, hands-on training. We can also help you from the factory by performing virtual FAT if that's your preference. We also have remote access to all of the analyzers, so we can perform any kind of remote control or service to facilitate the troubleshooting process for you. Galvanic's core purpose is always provide you with certainty. Our analyzers maximize uptime to help you quickly identify any upsets in your process. This automates custody transfer and avoids any serious issues from occurring. We have been doing this for 40 years throughout the natural gas value chain. And as you can imagine, being that long in the field, we have participated and shared our experience and a variety of events, conferences, seminars. So last year, we presented a white paper at the Western Gas Measurement Short Course. We shared our favorite learning moments to provide guidance to future operators. So if you haven't read that one, this might be a good opportunity for you to have a look. So with that, I would like to thank you for attending today's application training. We hope that you've seen the value in how our online analyzers and solutions can support your NGL operations. Please reach out to Galvanic team or your local representative if you have any questions or would like to discuss anything further. With that, thank you everyone for listening to this training, and have a great day.